Okay. Yeah, then comes part 3 and the last part of this question. Then we close it up. Okay, we are now looking at the calculations which are associated with photoelectric effect. The question says, let us digest it. The question says that ultraviolet light is incident on a metal surface of sodium metal. The threshold frequency for sodium is given here, and the maximum speed of an emitted electron from a metal surface is given here. So the first question comes and says, calculate the work function of sodium metal. So let me just brief you on what we mean by work function. Work function, actually, you need to know what is actually happening inside the metal. What happens inside the metal is that you have, in the center, you have a positive nucleus attracting the electrons to itself. So those electrons are held in position within that orbital by this positive charge in the nucleus. So if you are going to remove electrons from the metal, you need to do it against the positive charge which is attracting it. So it requires some bit of energy to do that. It's not a free deal. You need to pull electrons against the positive charge which is holding the electron. And that energy you supply to do that is what we call the work function. The energy you supply to oppose the glue which is holding the electrons in position is what we call the work function. So, when we are going to calculate it, what do we need to know? Okay, we need to know that work function is energy, and the same energy as incident energy. And we are giving it symbol W naught, that's internationally recognized symbol. And we know that in the energy in this field for the electric energy is given by Plancker's constant and frequency. But for work function, this frequency is F naught, threshold frequency. So when you look at this this equation, and the question is looking for our work function, and we are given threshold frequency, and the Plancker's constant is a constant. So it's like the question is already done. So all we need is to substitute. So this is what we get after substitution. Remember, Plancker's constant is 6.63 times 10 power minus 34, and this what was given as the threshold frequency. So after substitution, you get your answer as 3.799 times 10 power minus 19 joules. Remember, like I told you, work function is energy. Okay, now let us go to the next. We are looking at this case. The question says, calculate the frequency of incident radiation. So when you check the information we have here, you have sodium. They give you the threshold frequency of sodium. They give you the speed of emitted electrons. So when you look at the information, everything points to the general equation as put forward by Einstein. Says energy of incident radiation is equal to EK. We normally advise you to to use it in this format so that you can change it accordingly. So when you look at the information you have, first of all, what are you looking for? You're looking for the frequency of incident radiation. That one lies here. So you change this one to HF. Next, we have work function, but in the data you have the threshold frequency of the metal. So this one changes to HF naught to accommodate that. Then next you have the speed of the emitted electrons. So EK, you split it accordingly. So you have a half mass of electron, velocity of emitted electron. So that's the equation you have. And when you assess it, your work Planck's constant is a constant. That one we can update in from the data sheet. We are looking for the frequency of incident radiation, which is here. So here, this one is known, this one is known. So everything is known apart from what we are looking for. Next thing is to substitute and get the answer. Let us substitute and see what we get. So after substitution, this is what we get as the frequency of the incident radiation. So that is that, and we are going to cut this video here. We thank you for following us, we thank you for liking us, and we thank you for subscribing. Don't forget the channel is PSSB, Physical Sciences Silver Bullet, and the name behind the channel is Richard. We meet again.